Hello and welcome to another episode of Slam TV. I'm Professor Roger Yang and we've got a great episode for you folks. Today we're going to learn about how to calculate outliers. Last time we had talked about calculating outliers using the IQR method. Today we're going to learn a new method. Luckily for you folks at home, we've got a very special guest for you. I think you know who he is. I got J-Cho on my mind. I got J-Cho on my mind.
Say what?
J-Cho on my mind. I got J-Cho on my mind.
Thank you, Roger.
Hey Jay, how's it going?
Pretty good, slightly disturbed still. I can't believe you don't think I got 2,000 messages.
Well, last week we saw that you had 2,000 messages and we used the IQR method to do that.
Right.
Today we're going to learn about a new method, and this new method, maybe it'll be different.
Okay, how is it different than last one?
Well, the last method we used quartiles.
Okay. Ooh.
But this new method does not use quartiles.
Okay, I already like this, no quartiles.
Yeah. This new method uses something called standard deviation.
Okay.
Why don't you tell our viewers what standard deviation means?
Standard deviation is a number that tells you how spread the data is.
Doesn't standard deviation have some ridiculously crazy formula?
Actually, it's not that crazy.
Looks kind of crazy.
Maybe.
Anyways, the important thing is not calculating the standard deviation using the formula, but sort of using the standard deviation and understanding what it means.
Okay.
So why don't we look at an example where students can have a better grasp of what standard deviation is measuring.
Sure, let's take a look at it.
Here I see we have a couple of graphs, one blue graph and one red graph.
You mentioned about high standard deviation versus low standard deviation. Mm-hmm. How is that different?
Well, if the standard deviation is wider or larger, then that means that the graph is more spread out.
Okay, that means when standard deviation is small, graph will look differently.
Correct. So when I look at this blue graph over here, I can see that it's shorter and wider, so that means the data is more spread out.
Right, in this case, the standard deviation is actually 10.
Ah.
What do you think about the red one?
When I look at the red graph, I can see that it's taller and narrower.
Right, so in this case, the standard deviation is equal to 8, which is smaller than the blue one.
Okay, I get it. So the higher the standard deviation, the more spread out the data is.
Okay.
And the smaller the standard deviation, the less spread out it is.
Exactly.
So how are we going to use standard deviation to help us determine outliers, Jay?
Well, there's this convention where if you're more than 2 standard deviation above the mean, you're considered to be an outlier.
Wait, what? Maybe we need you can explain this with numbers.
Maybe it's easier if you look at an example.
Okay.
Let's use our math textbook cost as our example.
Oh, okay. The mean math textbook cost is $193 with a standard deviation of $64, right?
Right. So that means if you go 1 standard deviation above the mean, that'll be 193 plus 64, so you'll get $257.
Wow, $257?
I know.
And that's just 1 standard deviation above the mean?
I know, and if you want to go 2 standard deviation above the mean, so that'll be 193 plus 64 plus another 64. So that'll be $321. Wow.
So any textbook that costs more than $321 is an outlier?
Exactly. So let's say you got a math textbook that's $325. That's over $321, so it'll be unusually high. So it's an outlier.
Oh, but if you had a textbook that only costed $320, that's below the Outlier High cutoff. So
it's not considered to be unusually high.
Oh, I get it. College textbooks are so expensive.
I know, right?
And the math in the textbooks hasn't changed for hundreds of years.
And they come up with new edition every 3 years.
Man, I'm glad that Pasadena City College has embraced OER.
You mean Open Educational Resource?
That's right, Jay. Pasadena City College is the #1 community college in adopting OER. It saved students $4.2 million last year.
Wow, $4.2 million. That's a lot of math textbooks.
It seems like we just learned a new method of calculating outlier cutoffs using the mean and standard deviation instead of IQR.
Exactly, this is a new method.
Hey Jay, is $325 for a textbook always an outlier?
Well, it depends. For example, like chemistry textbook, I think they are more expensive. So it depends on the mean and the standard deviation.
Oh, that makes sense because chemistry, they have all those pretty pictures and stuff, and they might make new discoveries in chemistry. I can see why they have to update their textbook.
Right, exactly. So let's say, for example, the mean textbook prices is $225 and the standard deviation is 70.
Oh, okay. So how do we calculate the outlier high cutoff in this situation?
All right, so we need to go 2 standard deviation away from the mean. So the mean is 225 plus 70 plus 70. So that'll be $265.
You mean $365, Jay?
Exactly, Roger. I tried to cheat you of $100. Oops. So as you can see, anything above 365, which is the high cutoff, is considered to be an outlier. And 325 would not be an outlier because it's below $365.
I see. So it seems like we're learning how to calculate outliers using mean and standard deviation.
Exactly. Remember, we're talking about measure of relative standing. So it depends on how expensive your book is compared to other books. So in our chemistry example, $325 was not that unusually high because books are usually more expensive and it's not above 2 standard deviation away from the mean.
It seems like we're talking about measures of relative standing again.
Exactly. This is a new measure of relative standing. It's called a
Zscore.
The Z-score measures the number of standard deviation away from the mean.
In our math textbook example, the mean was 193, and we had a standard deviation of 64. One standard deviation above the mean was 257. This would give you a z equal to 1, because 257 is exactly 1 standard deviation above the mean.
Right. And getting the textbook costing $321, it will give you Z-score 2, because 321 is exactly 2 standard deviation above the mean.
What if the price is below the mean?
Well, let's say the book costs $129. So if you take 193 minus 64, which is 129, so you're 1 standard deviation below the mean.
Oh, since the 129 minus 64 is equal to 65, a textbook costing $65 would have a z-score of -2?
Exactly.
So the class that I'm taking has a textbook that costs $100. What would the z-score of that be?
Wow, $100? Is it a math class?
Actually, it's an acting class.
Oh, clearly somebody needs an acting class.
I object.
Well, the $100 has to come from the same population since this is not a math class. So let's just assume it's a math textbook, okay? Just for sake of argument.
Sure.
Well, $100 is between $129 and $65. So the z-score will be somewhere between -2 and -1.
Is there some way we can find the exact value of this?
Well, I'm glad you asked. Actually, there's a formula for the
Zscore.
Why don't we take a moment to explain this formulas to our viewer, Jay?
Right, as you can see on the top, on the numerator, there's x. X represents the thing that you want to find the z-score of. And you notice that x minus the mean, right?
Yes. For the numerator, we're trying to find out basically how far the data value is from the mean.
Right, so once you get that number, we're going to split that into standard deviation chunks.
Oh, in order to split it into standard deviation chunks, that means that we need to divide by the standard deviation.
Exactly, that's how the formula kind of works.
Cool, so why don't we calculate the z-score for this $100 math textbook?
As you can see, according to the formula, on top we're going to get 100 minus 193, which is going to give you -93. This makes sense because the distance between 100 and then 193 is 93. But it's negative because it's below the mean.
Next, we divide that number by the standard deviation, 64, and we get -1.453.
You got it, Roger.
I think I get it. Jay, I think we're ready to see whether getting 2,000 messages is unusual or not.
Right, in that case, we need to get the mean and the standard deviation of number of messages people receive from
What's your cosine.com?
I know the perfect person to call to get this information.
You don't mean...
That's right. It's time to call Hacker Heidi. Hi, Heidi.
Really?
Miss me?
If you mean in that sort of, I guess my paper cut finally healed kind of a way. Am I on speakerphone with you and that oaf again?
Hey, hi, Heidi.
What do you need this time?
We need the mean and standard deviation of number of messages received within a week from...
What's your cosine.com?
This is the last time, boys. I'll send you the results.
Thanks, Heidi.
Thanks, Heidi. Call me.
Hey, Roger, tell me if you think this sounds like a dial tone.
Oh, okay. Oh yeah, that totally sounds like a dial tone.
She's good. She really had me going.
Wait, she hung up on us. She sent us the statistics. The mean number of messages received in a week is 5.2 with a standard deviation of 2.7.
Right, let's try to calculate the outlier low cutoff. So 5.2 minus 2 standard deviation. So 5.2 minus 2.7 minus 2.7 will get you negative 0.2.
So the outlier cutoff is negative 0.2? What does that mean practically?
Well, in practice, you can't really receive less than 0 messages. So
Right.
getting 0 messages is not that unusual.
What about the outlier high cutoff?
Well, for that, we need 2 standard deviation above the mean. So 5.2 plus 2.7 plus 2.7, that gives you 10.6 messages.
Wow, you're like a super outlier.
Exactly, my hair's been on point lately.
And that profile you wrote, or I wrote, so poetic, so poignant.
And my skin treatment also, I get this mud mask, avocado, oatmeal, raisin bran, all that. It's been working really well.
Oh, we got a phone call. Huh, it's Hacker Heidi again. Hey Heidi, how you doing?
Yeah. So while I was digging around, I found a glitch in their programming. I decided to fix it for them.
What? A glitch? What glitch?
What's that glitch about?
You didn't get 2,000 messages, you got 2.
Don't worry, Jay. You still got 2 messages. Why don't we see what these 2 people with fantastic taste said?
Oh, it's too painful. I don't know. Can you just read it for me, please?
Sure, I'll read this message for you. Message 1. Welcome to whatsyourcosine.com, the dating site for people looking for love who love math. To log in...
Wait.
Well,
it's not even a real message. Give me the thing. Let me read the second message. Second message. We noticed that you haven't logged into your account. If you need help. Oh, but my hair! Slam, put me out of this misery.